Our lecture today is elastic impression materials. The definition of elastic impression material: it is the ideal impression materials for reproduction of tooth form and relationship, which can be withdrawn from the undercut area and returned to its original form without distortion. Elastic impression materials are subdivided into: first, hydrocolloidal, include agar-agar, it is a reversible hydrocolloid, and second, alginate, it is irreversible hydrocolloid. Second, elastomers include polysulfide, condensing silicon, additional silicon, polyether, and finally hybrid impression, it is a combination of silicon and polyether. Hydrocolloidal impression materials. Aqueous impression material. Hydrocolloid impression materials used in dentistry are based on colloidal suspension of polysaccharide in water. The colloid exists in two forms: in solid form, fluid, low viscosity, and random arrangement of polysaccharide chain. In gel form, high viscosity may develop elastic property when the long polysaccharide chain become aligned. In the right picture we see the solid form, and in the left picture we see the gel form. Hydrocolloids are classified into two types based on mode of dilation. First, reversible, called reversible because their physical state can be reversed. This makes them reusable by lowering the temperature, e.g. agar impression material. Second, irreversible. Once this set is usually permanent, so known as irreversible set by chemical reaction, like alginate impression materials. First, agar reversible hydrocolloid. It is an organic hydrophilic colloid, strong affinity to water. Polysaccharide extracted from certain type of seaweed. Presently it has been largely replaced by alginate and rubber impression material. The preparation of agar to clinical use requires careful control and expensive apparatus. When agar heated, they go into sol, liquefy, and on cooling they return to gel state. As we see in this diagram, gel by heating it becomes sol, and sol by cooling it becomes gel. Uses of agar. Widely used at present time for cast duplication during fabrication of cast removable partial denture. Second, full mouth impression without deep undercut. Third, crown and bridge impression, and finally as tissue conditioner. Presentation. Tray impression material. Gel form in collapsible tube for loading the tray. Each tube has enough material to fill a full arch. Water-cooled tray is needed. Second, syringe material. Packaged in a plastic or a glass cartridge that fit a syringe or in a preloaded syringe. The syringe material has different color, and it is more fluid than tray material and easy injected from the syringe and injected around the tooth. Third, in bulk container for duplication. Composition. 1 agar, 12% for a tray material, 6 to 8% for the syringe type colloid. The agar content is reduced in syringe type, so it is more fluid at the time of injection than the tray material at the time of insertion. 2. Borax. to improve the strength of the gel. 3. Potassium sulfate accelerator for model material to ensure a proper setting of gypsum cast against agar. 4. Alkyl benzoate preservative and antifungal agent. 5. Wax hard as a filler affects strength, viscosity and rigidity. 6. Dyes and flavoring trace to improve appearance and taste. 7. Water 85% as dispersion medium. Gelation of agar. The physical change from the sol to gel and vice versa it's induced by a temperature change. The gel must be heated to a higher temperature. Liquefaction temperature it is 100 degrees centigrade. To return it to the sol condition, it is transferred to gel at 37 degree to 50 degrees centigrade gelation temperature. If the gelation temperature is too high, the heat from sol may injure the oral tissue. In this diagram, we see the change from sol to liquefaction and sol and gel by changing the temperature and its change from liquefaction to sol and again to gel. Manipulation. Agar hydrocolloid require a special equipment. Hydrocolloid conditioner and water cooled rimlock tray. Hydrocolloid conditioner. Agar is normally conditioned prior to use, using a specially designed conditioning bath, temperature controlled water bath. Conditioning bath consists of 3 compartments, each containing water held at a different temperature, which are: first, boiling section or liquefaction section. The tube of gel is first placed in the 100 degrees centigrade bath for 10 minutes. This rapidly converts the gel to sol. The content of the tube becomes viscous. The sol should be homogeneous and free of lumps. Every time the material is re-liquefied, 3 minutes should be added. The tube is then transferred to second, storage section. 65 to 68 degrees centigrade temperature is ideal for storing the agar in the sol condition till needed. Temperature section. 46 degrees centigrade for about 2 minutes with the material loaded to the tray. This is done to reduce the temperature so that it can be tolerated by the sensitive oral tissue and also make the material viscous. If the material is maintained at this stage for a long time, it slowly begins to revert to the gel form. In this picture we can see the container with 3 containers, the device with 3 containers. B. Water cooled rimlock tray. Metal tray with a narrow bore metal tube attached to outer surface. The tube is connected to a cold water supply, 18 to 21 degrees centigrade. The circulating water reduces the temperature of the tray. The tray containing tempered material is removed from the bath. The outer surface of the agar is scraped off. Then the water supply is connected to the tray and the tray is positioned in the mouth. Water is circulated until gelation occurs. Rapid cooling is not recommended, ice cold water, as it can induce distortion. In this picture we can see the tray with the impression material. In this diagram we see the tray and the material and the tooth. that we want to make an impression for it. From the left side, the water is entered and circulated in the tray for cooling the material, and then it's go to the outside. Properties of agar. 1. It is hydrocolloid mucostatic impression. 2. It is cheap and it used in some laboratories for making duplicated models, reuse up to 4 times. 3. Very accurate reproduction of surface details because it is solid form, the agar is sufficiently fluid. 4. In gel form, it is sufficiently flexible to be easily removed. 5. Agar is high accurate at the time of removal from the mouth. Storage of agar impression is to be avoided. The cast should be poured immediately. Storage in air result in dehydration. Shrinkage and storage in water result in swelling of impression. It absorbs water in a process known as imbibition. The gel may also lose water by exuding of a fluid in a process known as synersis. During synersis, small droplets are formed on the surface of hydrocolloid, and the process occurs irrespective of the humidity of the surrounding atmosphere. If storage is unavoidable, it should be limited to 1 hour in 100% relative humidity by wrapping it in a wet towels, which result in least dimensional change. 6. Poor mechanical properties and low tear resistance, but it is better than alginate. 7. It is important to remove the tray by rapid snap action that enhance elastic recovery and decrease permanent deformation. 8. It is necessary to have reasonable thickness of impression material to limit the extent of deformation arising on removal from the undercut. 9. Working time range between 7 to 15 minutes and setting time about 5 minutes. It can be controlled by regulation the flow of water through the cooling tube. The advantages of agar-agar. 1. Accurate impression material if the material is properly handled. Second, it has good elastic properties and reproduce most undercuts area correctly. 3. It well tolerated by the patient and hydrophilic. 4. Cheap, no mixing required. 5. Can be reused when used as duplicated material, not recommended when used as impression material. Disadvantages of agar-agar. 1. Need special equipment. 2. Water-cooled tray is very bulky. 3. Low tear resistant. 4. Difficult to disinfect it. 5. If it is not poured as soon as possible, lead to low dimensional stability due to imbibition and synersis.
Hydrocolloids largely consist of colloidal agar-agar with water as the dispersion medium and various organic and inorganic additives. Like the base material for alginate, agar-agar is obtained from marine algae and has been known for centuries as a gelling agent for making pudding-like dishes. At temperatures of about 93 degrees Celsius, agar-agar forms a low-viscosity brine, which solidifies into an elastic gel at temperatures between 37 and 42 degrees Celsius. Both states can often be transformed into each other as you please by appropriate temperature changes. This behavior of hydrocolloids is taken advantage of when an impression is made. The material is inserted into the patient's mouth in a heated, free-flowing state, water cooled in the special trays, and removed from the mouth in an elastic gel-like state. A lot of work goes into hydrocolloid impression. Among other things, 3 separate water baths with different temperatures are used for material preparation. They comprise a boiling bath at 100 degrees Celsius, a storage bath of 60 to 65 degrees Celsius, and a tempering bath with a temperature of 42 to 48 degrees Celsius. The high-viscosity tray material is supplied in plastic or metal tubes, while the low-viscosity material for taking the impression of the preparations is available in sticks. They are inserted in special hydrocolloid syringes and heated in these. Double-walled trays facilitate the cooling required for curing. The cooling water flows through the tray's interior if required, and thus cools the hydrocolloid material through the tray wall. There are 3 partial so-called sextant trays per jaw, 2 for the sides and 1 for the front part. They each come in different sizes, as do the complete trays. The tray is connected to the water inlet and drain pipe through a hose system on the feeder base.
Second, alginate irreversible hydrocolloid. One of the most widely used dental impression materials. It is more popular than agar for dental impression because it is simpler to use. It changes from salt to gel by chemical reaction. Uses: 1. An elastic impression material for partial and complete dental prostheses. 2. To prepare study cast, not recommended for making impression of cavity preparation or crown and bridge. It does not give a high degree of accuracy. 3. For surgical splint. 4. For duplicating models. Presentation. It is supplied as powder mixed with water. Powder is packed in bulk container or a pre-weighed package for single impression. A plastic scoop is supplied for dispensing the bulk powder and the plastic cylinder for measuring the water. Types. Depending on the setting, alginate can be classified into regular set and fast set. Composition of alginate. Potassium alginate, hydrogel former, dissolve in water and react with calcium ion. 2. Calcium sulfate, dehydrate, provide calcium ions to react with potassium alginate to form an insoluble gel. 3. Filler, to control the consistency of the mixed alginate. 4. Potassium sulfate, contract the inhibiting effect of the alginate on the setting gypsum, giving high quality surface of the die. 5. Sodium sulfate, control working time, serve as retarder, react with calcium sulfate. 6. Quaternary ammonium, to provide self-disinfection. 7. Organic glycol, small amount, coat the powder particle to minimize dust during dispensing to make the powder dustless. 8. Pigments to produce color. 9. Reactive indicator. In some products give color change when setting is complete.
Perfect. Now you're gonna wanna put on your gloves. To keep that clean, have no gloves on. Okay, we're ready to mix. So make sure, again, you have your water correct to how many scoops and use the water container. Again, a lot of people don't use it, but I always recommend using it. So the key is time with mixing. And then I also use this little technique to help get the bubbles out. So what you're gonna do is add your water, gently stir in the powder so it doesn't make a huge mess. When it's pretty much covered, put lots of motion against the side of the bowl to make sure all the powder is mixed in and all the clumps are out. Once you notice that all the clumps are out, kind of get a lot on your spatula and go along the sides of your bowl like this. This really helps get all the bubbles out and makes your impression a lot better. Once you've gone around the whole bowl and all the bubbles are out, just take one scoop with your spatula all the way around and you're ready to load it into your tray. And that, again, will make it nice, smooth, with no bubbles.
Properties of alginate. 1. Alginate has well-controlled working time but vary from product to product. There are regular setting and fast setting. Setting time for regular set is from 2 to 4.5 minutes. Setting time for fast set 1 to 2 minutes. Lengthening the setting time is better accomplished by reducing the temperature of the water used with mix from 18 to 24 degrees centigrade. The clinical setting time can be detected by the loss of thickness of the surface. 3. The material should be left in a place inside the patient mouth for 2 to 3 minutes after the thickness has gone from the surface, since the tear strength and resistance to a permanent deformation increase significantly during this period. 4. It is mucostatic and hydrophilic. 5. The tail reproduction is lower than compared with agar or elastomers. They are not recommended for crown and bridge. They are popular for partial denture work. 6. Set alginate is susceptible to evaporation, sinuses and imbibition, like agar, so the cast should be poured immediately. If storage is unavoidable, keep in humid atmosphere of 100% relative humidity result in less dimensional change, not more than 1 hour. Seven. Like agar, snap removal technique need to be employed in order to get an elastic response. The permanent deformation is somewhat higher than agar. 8. Has lower tear strength than agar and have poor mechanical properties. 9. Set gypsum model should not remain in contact with the alginate impression for a period of hours because contact of a highly soluble calcium sulfate dehydrated the alginate gel containing a great deals of water is determinant to surface quality of model. 10. Thin layer of alginate is weak. The thickness of alginate between the tray and tissue should be at least 3 mm. 11. Alginate does not adhere well to the tray, therefore perforated one or rim lock should be used. 12. Mixing time for fast set 45 seconds, while for regular set 60 seconds. Over mixing result in reduction in final strength as the gel fiber is destroyed. Also reduction in working time, while under mixing lead to inadequate weighting and reduced strength. Also the mix being granular and poor recording of details. 13. The dentist can control the setting time by alter the temperature of the water you use for mixing. Colder the water, the longer the setting time. Warmer the water, the shorter the setting time. 14. It has a pleasant taste, smell, and low cost. 15. It is highly elastic but less when compared to agar. The advantages of alginate. 1. It is easy to mix and manipulation with minimum requirement of equipment. 2. It has suitable setting time. 3. Flexibility of the set impression. 4. Accuracy if properly handled, low cost. 5. Hydrophilic, comfortable to patient. Disadvantages of the alginate. 1. It cannot be corrected. 2. Poor dimensional stability due to synersis and imbibition. Poor tear strength. 3. Low detail reproduction. 4. High permanent deformation. 5. Difficult to disinfect. Thank you for your listening.